All right, so in this video, we are going to take a look at a few things about Rust once we get it installed. So one of the things is if you're wanting to check the version, you can run this rust up command. And this, if you put in a -- version, that'll give you the version of the application that you're running right now or the programming environment. You also Now I've created a folder called source rust, so I put all of my source code in a common place so that I can find it. I'm going to do an ls here, and you can see that I've got a notes file that I'm putting notes in as I learn how to do things. And then I've got a folder here called tests that I'm creating all of my test stuff in. But in this video, we're going to actually be working on a real live program. And so I'm going to describe how this program works, and then we're going to create an actual program using Cargo. So we'll see how all this works. So this application, there's a number of parts lookup systems that are out on the market that our business system has to interface with. And those programs all share somewhat a common interface. So what we're going to be doing in this application, and so just to kind of give you the evolution of this, we originally had a Java application that we would call for this parts lookup interface. And Java got to be such a problem trying to keep the versions updated, and the user would get a new version of Java and it would break all of the code and stuff, that we decided to rewrite the application in Go. And so we did that. We went through and rewrote the application in the Go programming language. And, part of this whole process is we're looking to see if we can replace all of the Go stuff with Rust. And if we do, what does that look like? How complicated is it? And, is it something that we want to mess with? So the process is basically this. The parts lookup program calls this application. It passes it two things. It passes it an input file, and it passes it an output file. Now, what the program is supposed to do is it's supposed to open the input file, grab the contents of it, and pass it up to a REST service that we have that runs on one of our servers. So it grabs the information it needs from the local system, passes it to a REST interface, and then that REST interface takes the data, processes it against the business system that's related to this particular customer, and then sends back data that will then get put in the output file, and then it will delete the input file. And upon deleting the input file, it tells the calling program, which is the parts lookup system, it tells it that it's now okay to go open the output file and get the data that you requested. And so it's a pretty simplistic process. It's not very complicated, especially at this level. A little bit of complication on the server side because it has to actually process that input file, but it's not really a big deal. It's pretty straightforward. So that's the first application that we're going to be building. Now, once we're done with this, the next step is we're going to go up to the server and we're going to take a look at writing another REST application that is going to replace the PHP file that we have up there that's actually processing that request. So our goal here is to write a Windows-based system that handles the request coming from the parts lookup system, and then we're going to write a Linux-based system that is going to run on a Linux server and listen for REST requests to come in, and then it will handle the interface back and forth that way. So the first step is, how do we create this application? And so that's where Cargo comes in. And Cargo is actually a pretty cool process, because you're going to see here that it actually gets us started, but then it also handles requirements. So if I need to go and download a library to handle a certain thing, let's say the networking stuff, when we get ready to do it, then we can, I don't know what the Sparky. I don't know what my dog is over here trying to bury something in the carpet. But the process that we're going to be using, if we need to download, say, the REST processes or the JSON stuff, because again, I don't really know how Rust handles all this stuff, but Cargo handles going and getting all the libraries. So by defining what's in this file that you're about to see, it allows us to go in and tell Cargo what we want to do. Cargo also goes and builds the application. It'll build the release of the application and all that kind of stuff. So it's a pretty cool system so far as I can tell. So we're going to say Cargo, and when we do this, I'm going to jump back over here, and you'll see this is just kind of the way that I do things. So I have that notes.txt file that is in the Rust folder. And as I learn how to do things, I'm going in and making little notes in here so that I have them with the data. So you'll see here it's Cargo build is how you go in and actually build the application. You can tell it to Cargo check, which basically goes and checks your application, but it doesn't spend the time to actually build a binary yet. So if you're just wanting to check to see how you're doing as you're going through writing your code, you can run Cargo check. And then Cargo run will actually go build the application and run the application. So and then you'll also notice down here we've got Cargo build -- release. That will actually build the final release, which gets rid of all the debug information and all that kind of stuff and makes the thing run really, really fast. So this is what we'll do when we get ready to actually release the program. But right now, what we're looking at is up here where we're going to do a Cargo new, and then we're going to give it our application name that we're actually working on. And so we're going to type in Cargo new, and then I'm going to call this thing PSL. That's just the name that we've given this thing many, many years ago. So we're going to be creating a Rust application, a Rust REST application. And we're going to call it PSL. So we're just going to tell it to create that. And so now if we do an ls, you can see that we now have a new folder here called PSL. So if we go into the PSL folder, you'll see that we have a source folder, and we also have a file here called cargo.toml. And if we VI that Cargo file, this is where we go in and give it version information, other things about the application that we want to have. And then down here at the bottom is where we add dependencies. So if we end up having, let's say, a REST dependency for some package that we need for the REST stuff, I'll add that to that dependencies, and then when I do a Cargo build, it will actually go out and build that particular or pull down and then build that library so that it's accessible from our application. So we'll get into this file a little bit more later. Right now, what I want to do is I want to cd into the source folder, and you'll notice that it has created a main.rs file. Now, the main file is the one that the application is going to start with, and just like in C and Java and C++ and a lot of other environments that are actual compiled languages, we have a main function that is going to be called to get everything kicked off. So it's the starting place for the entire application. Now you'll notice that they don't use function. They just use the word fn to declare that is a function, and then main, and then an open close parenthesis, and then your curly brackets to go around the actual function. Now, for those coming from Python, you're not used to seeing these braces, and it's probably the single biggest thing that I hate about Python code is that you don't have those braces. In Python, it uses only the fact that it has spaces or tabs to determine what's inside of a block, and it makes it very, very difficult when you're looking at a lot of code to figure out what is doing what. So I definitely prefer having the braces or the curly braces around the code, the blocks of code. So this is the very first application that it has built, and it gives us a print line. Now there's something funky here, and I haven't actually learned about this, so I don't know what the point in it is. But in every other, like C and C++, you've got a print line function, and it is a function that you're calling, and then you pass in the text that you want to actually print. And you'll also notice there's a semicolon on the end to designate that this is the end of the line. Well, this, because it has an exclamation point on the end of it, it is telling it that this is actually a macro. It's not actually a function that we're calling, it's a macro. Again, we're going to learn what a macro is exactly as we go through this. But right now, just know that if you're going to do a print line to print out at the program line, you've got to put an exclamation point at the end of it. Everything else here works just like C and C++. So it's pretty straightforward. In fact, it works just like Python for that matter. You just don't have an exclamation and it's print instead of print line. But otherwise, they're very similar code. So let's take a look at what this actually does. So we're going to close out of that, and we're going to do cargo run. And again, I could do cargo build, and it'll go out and build the application, but that's all it did. And so if we cd back here, we end up with a target folder. And if I go into that target folder, it creates a debug, and it'll eventually create a release version when we create a release version of this. But we're going to go ahead and go into the debug folder, and here is where it has gone in and created our PSL executable, or our binary that we're going to be running. However, if we go back over to our source folder, and instead of typing cargo build, we type cargo run, this is going to build the application and actually go run it. And so here you can see that it's actually gone in and created hello world. Now, if we do a cargo build -- release, this is actually building a release version. So again, we're going to go into target, but this time you see there's a release folder, and here is our release version of the PSL. Now, if we do an ls-al on PSL, and then we do an ls-al, and we're going to back up a folder and go into the debug folder, PSL, you can see that in this particular application, they're they're really doing the same thing. So there's very little difference in the size of the file. But as you get more and more code and functions and other things in there, you'll start to see a divergence here on the size of your file that you're going to be releasing versus the one with all the debug info in it that is building for your testing. Now, I don't have any experience with this, but I hear that the build process when you're building for a debug environment is a lot faster than building for a release. Obviously, you don't do a build for the release that often, so it's really not that big of a concern for me. But the build process itself is supposed to be a lot faster, and it is building a lot of other things into the application so that you can debug it more easily and test things. So that is our process for actually creating a new application. And so in the next video, we're going to actually start diving into how to actually do some of the things that we want to know how to do.